Hello everybody. In this video, we will be talking about expressions. Now, this video may be a little bit dicey because of certain things that you need to recall. However, I got you covered and you're going to be just fine. For this lesson, you would need understand factoring, understand expanding, understand equivalence, understand evaluating at the value, polynomial, like terms, and integer rules. So let's start with dealing with the integers. Suvine! Of course, that's my native language to saying remember about integers. And the reason why I throw a little bit of those foreign language pops that here and there is only because you're going to realize that math originates from all over the world. So there's going to be some stuff that comes from Europe, some come from Africa, some come from Asia, and just stuff like that. So integers, which we denote as the symbol Z, which originated for Germany, Z being the German word for number, Zahlen. Anyway, integer, the word itself, comes from Rome, Latin origin, means whole number. What? What do you mean by whole number? Of course, when you was learning earlier arithmetic, you only know whole numbers as you never taught negative numbers, but now since you get into intermediate arithmetic, you learn a thing or two about whole numbers having negatives as well. So they include zero, negative numbers, and always use in terms of distance from zero. Meaning how far is this or that from whatever, what's the difference? All this and all that. And again, I drew you a little number line from here to there so you could get a good understanding of how to recall integers. Now, we're going to take this a little bit further and talk about the rules dealing with those negatives. Because remember, integers have positive numbers and negative numbers. Pas oublier means don't forget. Because oftentimes we do forget about the negative numbers also. Let me help you out and explain every part of it. So when you adding and subtracting, and don't forget dealing with negative numbers. So when A is bigger, negative A plus B equals negative C. Let me give you an example of this so you can understand the example of it. So say you got negative 7 plus 2. You can look at this multiple ways. Like kids often look at it in terms of which one's bigger, the positive 7 or the negative 2. And you would say negative 7. So if I'm at negative 7, don't forget to draw your number line. And then if I go up 2, because I'm moving in a positive direction, which I go right, negative 6 is 1, negative 5 is 2, so the answer would be negative 5. You can make up a situation saying that I owe you $7, but I paid you $2. But I still owe you because the money that I owe is much more than the money I paid you. So as a result, I end up with negative 5. And that's when the negative number is bigger than the positive number. So what about if a is smaller? So, for example, negative 3 plus 5. And the best way to understand integers and to recall it is always associate yourself with money with this. So, I owe you $3, but I only have a $5 bill, so I gave you that. Do I owe you any more money? No. Why? Which one's bigger? The $3 I owe you or the $5 I paid you? The $5. And as a result, my answer is going to be a positive number. And so, with that being said, you owe me the change of positive 2. Alright. Forgive my allergies, y'all. Sorry about that. When two negative numbers touch each other, what I mean by two negatives, the two subtraction signs. One thing I do want to make clear, so you guys can understand this a little bit better. Negative is the same thing as subtraction. Alright? Minus, they're all the same thing, so don't get thrown off by that. So when you got two negatives or two minus signs touching each other, it becomes positive. Later in the video, you're going to see a little bit more about the whole negatives a little bit further in a unique way. Not in this video, but I believe the next one that I will create. So, we got 7, and this is an example. 7 minus or negative, however you want to say it. I always prefer 7 subtract negative 2. And again, the two negatives become a positive, so 7 plus 2 equals 9. And again, I'm taking my time to review this for those who kind of forgot about how to work all of this. So if you personally don't need to watch this part, you could of course move on to other sessions of this video, because I'm telling you, it's a lot. Alright, so let's get back to it. When negatives don't touch each other, so say if I got negative 2 minus 3, guess what? That's a negative 5. I know you guys don't want to think of it as that way, but let me draw a number line to help you out with that. Always, if you get stuck with any part of these negatives, always draw yourself a number line to kind of help you understand. So this is 0, negative 1, negative 2, negative 3, negative 4, and negative 5. So, I owe you $2, right? But I borrow $3 more from you. Where would that take me? So if I borrow 1, that's $3. If I borrow $2, that's 4. If I borrow 3, I owe you $5. And because I owe you, it ends up being negative 5. Alright? And those are the rules of dealing with adding and subtraction. So what about multiplying and dividing, which is much more easier? So when you multiply and or dividing, when you have two negative numbers, you end up with positives. So let me erase this. So if I say negative 7 times -2, that's going to be a positive 14. Think of it this way when you're looking at this. You got two bad guys who took each other out. You know, they got into a fight or what have you, or let's think of it realistically in terms of middle school. Two people who you don't like, who you dislike, both of these two people got into a fight. And of course, it's a good thing for you because guess what? You got some entertainment. You get to, watch these two people fight each other, and you get to, film it with your phone or do whatever middle school kids do. By all means, of course, therefore, instigate such things like that because filming a fight on your phone, and of course, posting it, you could get in trouble for that too. Don't know the specifics of how and the why, but I know from other places you could get in trouble for that. So, anyway, getting back to the point. Two people who you don't like finally fight each other. It's a good thing. And the good thing is always a positive thing. That's what you think about. So, what about if I have 4 people find each other? -7 times -1 times -1 times -2. When I multiply all these, -7 times -1 times -1 times -2, because it's an even number of negatives, I still get a positive 14. So I don't have space to write that out, but you get it. So highlighting the point of this, when you got two or even numbers negatives, 2, like you see here, 4, 6, 8, 10, any even number of negatives always going to result to a positive answer. So what if I have 1 negative number if I'm multiplying or dividing? Guess what? I end up with a negative answer. So -7 divided by 1, that's just -7. So as a result, that's it. And you could say -7 times -1 times -2. That's still going to be a negative number, but that'd be -14 because of it being the odd number of negatives. And again, that's how you operate with multiplying and division. So I'm glad to help you on that one. All right, we'll be right back. So at this time, we're going to be having a little practice, and we're going to get ourselves into a little bit of Kahoot. So remember, you got to get in first place to receive a little prize. Welcome back. Let's talk about some other math rules which will help us out. So you got three properties here. You got associative, distributive, and commutative. So let me work with commutative first. So our commutative is saying that if you add 2 numbers together, the order does not matter when you are adding. Notice that when you add, it works, and for multiplication, it works too. Now, later on, again talking about that incoming video, you're going to see why the commutative properties work for addition and multiplication. So you see the examples there. Let me change that color. Do it in yellow. So you see this example, 5 plus 3 equals 3 plus 5. That's a true statement. Doesn't matter where you swap the numbers, it works. So And that's the same for multiplication. 3 times 4 equals 4 times 3. All a true statement. All right. Let's talk about associative property. So commutative mainly deals with two numbers. So what if you end up dealing with three numbers, two of them being cased in the parentheses, plus a C? Of course, when you think of associative property, you got to think about your order of operations. And you know what the P stands for? The parentheses. So that means that anytime you see the parentheses, work on your parentheses first. So in this example, 4 plus 6, in that parentheses you get 10. And you know that 4 plus 6 in that parentheses plus 2 is equals 4 plus, with the parentheses of 6 plus 2, it all equals 12. It doesn't matter how you put the numbers, they're going to equal the same. And believe it or not, it's the same thing for multiplication as well. So let me write this down. So 4 times 1 times 2 equals the same thing as 4 with the parentheses of 1 times 2, because essentially that all equals 8. And that's essentially what the associative property is about, which ties into my favorite, show you arrow, distributive property. That's what I like about the associative property, because if you could do the associative property when you deal with multiplication, that's just it. And believe it or not, the distributive property is the associative property of multiplication. And again, the associative property, the distributive property is the associative property of multiplication. So this right here that I showed you in yellow, which you could barely see, is just that. So distributive property is the associative property for multiplication. Because let's go back to the commutative property. You know that there's two types, right? One for addition, one for multiplication. Well, associative is just for one, only addition, and the distributive property is still associative property, some technically, but it's for multiplication only. So this in yellow is not really needed. And of course, if we have to be all mathematically correct, associative property, distributive property is mainly a bit different, because only the distributive property only deals with multiplication and associative solely deals with addition. All right, so let's move on. So identify these properties. Show me what you got. So 9 plus 3 equals 3 plus 9. What property is that? All right. And what about the property shown to the right? And what about in the middle, which you know that to be, which kind of property is that? But for this one, I kind of want you to solve this one, because this is this property in the middle, which I'm waiting for you guys to call it out. Of course, it's distributive property. And we know that the first one to the left is commutative, and the second one is associative. So for the distributive property one, you have to be able to multiply it. So 5 times 30 is what? 150b. And what about 5 times 20? 100. How I wrote this, those two ways of how I read it are going to be very, 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 very important within this lesson. Right? So be aware of that. We'll be right back. We're going to play ourselves a little Kahoot, have a few little fast activities, and get back to it. Welcome back. Now let's talk about what is an expression. An expression is a mathematical statement. Now, let me emphasize a mathematical statement. It's not a complete statement, it's just a statement. It's not a complete thought. Because, like in the English language, you have to have a subject, verb, and predicate. I very hungry. That's a complete sentence. I have a subject and a verb. The subject is I. The verb is am. And of course, I got very hungry to describe it. I got even the adjectives. So, an incomplete statement would be, or a sentence would be, go sleep. That's not a complete sentence. It just said go sleep. So in mathematics, expression as we call it is it's just a incomplete statement. Because of course, you don't really use the word sentence when you talk about mathematics. So expression, incomplete statement, which is made of groups and terms of numbers which are separated by operations, plus, minus, any operation signs you could think of. In this example, you have the 5x plus 2. So the x, of course, is the variable representing the unknown, and the numbers you see in front of the numbers you see in front, the number you see in front of the variable, you call that a coefficient. And any numbers that are in front of the operations, such as this 5x and this 2, you call those terms because they are numbers that are separated with a operation. This operation in this case is a plus sign. And again, I do apologize about my handwriting, so I will write coefficient a little bit better. There we go. So, factor means find the greatest common factor. Expanding means to multiply. So let me ask you this question. If I'm saying find the greatest common factor, how will I do that? You got to think of division. So let's go get to it. So factor. Find the greatest common factor. Of course, in order to do that, you must divide. Now, let me pause it right here and emphasize this. You don't have to use the word division. I like dividing. But you could do other things like prime factor trees. Like, for example, 24 and 60. All right. What do I know? When I multiply together, it gives me 60. 60 times 1. 30 times 2. 20 times 3. 15 times 4. 12 times 5. 10 times 6. Those are all the factors that I know of that. Now let me do factors of 24. I know 20, let me do this in a different marker. 24 times 1. 12 times 2. 8 times 3. 6 times 4. And that's all I know. So the question remains, again, I'm looking for the greatest common factor. I'm looking for the number. I'm looking for a factor, the biggest factor that both 24 and 60 have in common. So get my highlighter. I'm going to go ahead and search biggest factors that they have. If you want to make this a little bit easier on yourself, you can identify what they have in common. Like I know that they have a 1 in common. I know that they have a 2 in common. I know that they have a 3 in common. I know that they have a 4 in common. I know that they have a 6 in common. And then I also know that they have a 12 in common. Now, you highlight all the factors that they have in common. What's the biggest? If you say 12, winner, chicken dinner. You got it right. It is 12. So, 12 is going to be placed on the outside. Put in the parentheses. Now, to get 24, what times 12 gave me that 24? And don't forget about the x, because remember, you're trying to get all this to go back to this guy here. Plus, because the answer was a positive, what times 12 gave me 60? 5. Brilliant. And that goes that way. You are really doing a good job. Not bad at all. Just like that. That is how you factor. All right. Now, another method of doing this if you really wanted to, you go ahead and divide it out. My preferred method. So, which is the same thing as factoring. So, I know 24 divided by 2 is 12. I went with 2 there. you know. And then for 60, now I'm going to use this 12 because that's what I started out with. 60 divided by 12 is 5. And I decided to just take it like that. Because again, when I divide 24 divided by 2, I get 12. And then I want to see, can I get that same 12 when I divide by 60 to the 5? And the answer was yes. So I get 12, 2x plus 5. And that's just another way of doing it. Now, if you know how to find the factors and do all that in a timely manner, you know how to deal with this, so you got no problems to worry about. And this method is fine for you. But if you don't have the mastery graphs, just do what I did in the previous method. Breaking up all the factors, when I multiply them together, gives me 24. And then the same thing I did with 16. And then I list highlight all the factors that they have in common. I look for the biggest one, and that was it. Again, I wrote out the GCF is going to be always out in the parentheses, and the numbers that gave you that 24 when you multiply is all going to be here. I will call that the leftovers. So, or if you want to be technical, non-common. So when I say non-common, it means that these two numbers inside the parentheses are not in common with 24 and 60. 5 is in common with 60, but has nothing to do with 24. 2 does have something to do with both 24 and 60, but again, not all of this is in common with those two numbers. So again, I call it the non-common. All right. All right, expanding. How are you going to expand? What does it look like you're going to do? Guess what? Remember the distributive property that I was telling you so much about? You're going to do it right here. All right, chill. Now, remember, distributive means multiplying, taking a number, which is, believe it or not, that's the GCF. 7 is the greatest common factor that is outside the parentheses. And you multiply by the non-common factors. Multiply by the non-common factors. So 7 times x minus, 7. I'm tripping. Sorry about that. Minus 7 times 5. So 7 times x is 7x. 7 times 5 is 35. But remember, there was a minus sign right there, so you put it right back where you had it. Whoop, there it is. You're done. Just like that. And you realize that expanding and factoring, they go hand in hand. They inverses of each other. Because look what you did here. So you went from here to right here. Just like that. Brilliant job. And this is just more additional practice, which, find the terms to make this happen. So, how are you gonna make all this happen, y'all? So, you got 40y here. How you gonna make all that happen? 2 times blank gives me 40. Y. 20y here. Brilliant job. 2 times negative 6c. 2 times blank gives me negative 6c. Negative 3z. So write it in factor form. And believe it or not, this is pretty much already in factor form for you. So all this right here is all factor form. Because the greatest common factor of both 40 and 6 is 2. And you could list the factor trees if you need. Just like that. Because again, just list your factor trees the way that we was doing, and you're going to realize that this 2 is your greatest common factor of both 40 and negative 6. And a non-factor. All right, so you guys try this out, and I will discuss this in class. I will not be responding to it in the video. So, I do want to address something right quick in here. That here, you have to try out your law of exponents knowledge. They're going to come to handle that. What I mean by, what is the smallest exponent do they both have in common? So you have 8n to the first and 2n to the power of 3. What number of exponents do they both have in common? Well, they both have an exponent of 1. So you could write n3 to be n times n squared. So I want you to think about that. All right, you can do the rest. All right, I want you guys to try these few problems out on your own. Now remember, factor expanding are opposites of each other. So when you see a formula like this, your GCF has to be outside your parentheses, and then your non-commons have to be out here. Here, of course, when you are to expand, you simply just distributive property. So you should have 3 different terms. So ax plus b something plus c something, whatever you get from that. So you know what it means to factor, and you know what it means to expand. So you guys try that out. Equivalence. Now things about to get real up in here. Two expressions are equivalent if they are the same and written in standard form. In standard form, all it is just combining like terms. So don't even get stuck with all that drama. So let's do this. Put 4 plus 9p in standard form. Well, in this case, since I gave you this definition of standard form, just combine your stuff together, you get 13p. Alright? But 13p, you could write down another way too. And those things I'm about to show you are not standard form. This is not standard form. This is shown as equivalent, which I will be asking you to do that for me. That's showing equivalence. So you guys show that that's equivalent to 13p or equivalent to 4p plus 9p, which is all equal to 13 when you combine your terms. So here's a little challenge for you. 7p plus 21p. Of course, you're going to say, oh, that's just 28p. And you'll find ways of rewriting 28. So my question to you is, how would you write that in factor form? Because this is expanded. What about factor form? So I'm not going to do that part for you. You would do that by being signed in the Google Classroom, where you will answer that question in Google Classroom. So show me that 3 in the parentheses x plus 5 and 2x plus x equals 15 are equivalent. So you're going to have to show it. And this is something that I would tell you to pause. Work with a partner to figure this out. All right? Pause. Figure it out. And of course, since I know many of you guys are going to try to play forward through the video just to get the answer and copy and paste, I will not be doing this in the video for you. However, in class we could discuss it, and you could use those previous examples that we just did, or example. So try it, we're discussing in class, and we're going to keep it pushing. All right. Which expression is equivalent to 8 times 3r? You guys are crafty. Good job. It is 24r. Which equivalent is equivalent to 4k plus 6? Now, combine your like terms. I know I told you that's what equivalence is pretty much all you're doing. That's not going to be the case. This goes back to distributive property, and this is all about expanding that function. Expression. And when you do that, you should already know what you get. If you say 4k plus 24 is your answer, brilliant job. Because it's all multiplication. Anytime you see a parentheses, you're going to multiply. Can I add k plus 6? No, they got nothing to call it. So boom. So 4 times k, 4 times 6, you get 4k, 24. Whoop that is. All right, keep it pushing. We'll be right back after these messages. take yourself a mental break. This is part where you need to compress because you've been doing a lot. And we'll be back on momentarily. And we're back. Here's a piece of definition for you to try out. A polynomial expression with one variable symbol in the standard form if it's expressed as this crazy notation, which you guys seen this before, or if you haven't, this is your first time seeing it. So you got something that looks like this. Notice how the powers decrease from 2 to 1 to 1. And what type of function is that? You will find out. You will know that this is a quadratic function because of this, but this is also called a polynomial because you have more than one term. You have an expression with multiple parts with exponents bigger than 1. So when you got exponents that decrease, you have a polynomial. So let me say x third, then you have x second plus x to the first plus some random number. We're going to call it c. So that's another polynomial. So you have more than 2 terms because you know this is a binomial. Poly is more than 2. That's not, this is. All right. Ooh, remember this? Of course you do. Combine like terms. This is the real skill to put you to the real true test. If you got this together, you got it going on. So to do that, remember, you see this negative sign, apply the negative rules, distribute your negative signs here, here, and here, which makes that negative 5x squared. Why is that? Why it becomes negative? Positive times negative is a negative. And then here you got a negative 21x because positive times a negative is a negative. So what about this negative 47 times that negative? Positive 47 because 2 negatives makes a positive. So in mathematics, you got to think of it. 2 negatives is a good thing because it becomes positive. That's just me trying to be corny there. All right. Now we could combine your terms. Combine what you have alike. Alike. So don't forget to use those integer rules. So if I have $2, but I owe you $5, do I still owe you? How much do I owe you? Good job. If you struggle with this, just remember that 5 is bigger, and since it has a minus sign or a negative, your final answer is going to be a negative answer. All right? So what about here? Negative 17x minus 21x. So look, let me ask you this question. Are the negative signs touching each other? They're not touching each other. So that means because they're not touching each other, it's still going to be a negative answer. So with that being said, who is bothering me at this moment? I'm sorry, y'all. Let's go ahead and do this. So that means your final answer should be negative. And that is going to be a negative 38x. I know I got to quit writing with that, y'all, because you guys won't see it. So, a negative 38x. Again, the negatives wasn't touching each other, so guess what? I'm going to have a negative answer. So if I got a negative 7, but positive 47, what should my answer be? Since 47 is positive, bigger than the negative 7, you're going to have a positive answer. Remember, when you are adding with opposite signs, whoever's the biggest, in this case the positive 47, you should have a positive answer. So if I owe you $7, but I paid you 47, you just owe me just $40 back in my change. And I want my change. Now let me come off the screen now. Just like that, y'all. That's how you do that. Okay, you try this one on your own. This situation to evaluate. Plug in for x, that's all it is. So, given a calculator, Google or wherever you have at home, just plug in for every x you see. So don't forget to use your parentheses. So 10 squared is just 10 times 10, right? So that's just 100. I'm going ahead of myself. I shouldn't be going that fast. So for every x you see, you just plug in a 10. So again, you got to take care of your PEMDAS. Don't forget about your order operations. Apply that. I'll let you figure this one out on your own. Alright guys, this has been a workout. So we are good. I'm going to put this on pause from here. Thank you guys so much.